Happy Halloween. Oh,
Oh yeah,
let
it's
me,
true. It's today. Oh, yeah,
Yeah, happy Halloween.
Halloween.
Yeah.
Happy to you too.
yeah, I'm at home today. I think work's deserted, but yesterday it was at the office there were a lot of people in costume. It was a lot of fun.
Where is home, Drew?
I live in Rockland, so
Oh,
yeah, near Sacramento,
okay.
but I work in Mountain View, so
Yeah, that's what I was wondering.
yeah, my commute is longer than most.
But you have a cool toy to commute.
Yeah, although right now I'm kind of grounded. My brakes are shaking when I land, and they work, but I need to get them repaired or I'll damage the wheels. So uh, I need new brake discs, I think. So I'm waiting for the brake discs to get replaced.
Don't
Always
you drag
something.
your foot just to slow you down?
Yeah. Well, the wild thing is that on most general aviation planes, there's no steering wheel on the ground. So you steer with the rudder pedals. And on some planes, you steer the nose gear, but on a lot of planes like mine, they just have castering nose gear. So if you want to steer, you tap a toe tip. You touch the top of the brakes, and it brakes that wheel, and it makes the plane turn that direction.
Hmm.
And so the first few times I was with an instructor and we're taxiing, I'm like, who's steering the plane? Because the instructor's hands were not on the they were not doing anything, but we were going down the taxiway. And I was like, how does this work? And
So it's heavy use of the brakes.
very much heavier. Well, on the ground. Like
Yeah, yeah.
I think overall, it's less, but on the ground, it's very heavy.
Mhm.
Yeah, a little different. And I land on a really short runway in Palo Alto, so you really want your brakes to be good because you're going to use them.
You have one of those Bush airplane,
No,
20 feet takeoff.
no, I have a Cirrus SR-22 turbo, so it's not a bush plane. It needs a runway. So, so that's why I have to be really careful. There have been people that landed at Palo Alto that didn't stop successfully, and so there's a fence at the end of the runway right now. It's down because a plane, came in fast. He didn't stop. He went, and there's a berm because it's right on the edge of the bay. He went through the fence, over the berm, and then into the water.
Dang.
An expensive way to mess up your day. He was okay. I don't think he was hurt, but um, well, you
How
weren't.
much is an insurance? Like we need car insurance for our cars, right? So I guess you need insurance for your plane. How much does it cost a year? Like to
Probably 5 or 6 thousand, depending on your.
okay.
It depends
Wow.
on, but it depends on the cost of the plane. I have a more expensive plane, so I pay more. But
Mhm.
then also, it depends on your experience level. And so my experience level, because I do it every day, is extremely high for a general aviation pilot. But I have a relatively expensive plane. It's not a 1960s plane with a lot of them, and so it keeps my insurance rates a little bit high. But don't have an accident because then it'll be really high. So we're just chatting while people join. Thanks for joining, everyone. Um, so it looks like I think we have a pretty good crowd today. And Sidhira, I don't know if you've introduced yourself or not. If you have, please forgive me, but I think you're new, aren't you?
Yes, I just heard about this during the conference 2 weeks ago. I just learned about it when I was looking through the website. The topic seemed interesting, so I just wanted to join and see, just learn what you all are doing. Um, so I'm Sudhira. I work for NetApp. We make storage hardware. I'm in the NetApp hardware team.
Okay. Well, welcome. We're really happy to have you.
Thank you. It's nice to meet you as
Yeah.
well.
Yeah, it's wonderful to have you here. And yeah, we have one of your, so I don't know if you know Mita Sagi from Pure Storage. She also is pretty regular attender. So um, anyway, it'll be interesting to hear you all bring up the concerns you have from the storage perspective. So that's wonderful. We really appreciate you joining us.
Yeah,
Sounds good.
welcome to the team.
Thank you.
Yeah, absolutely.
And
Nice.
then I think Edlick was here before. So welcome back, Edlick. Thank you for joining us.
Yeah.
So so as we had started today, um, I think, I don't, you guys, I don't know if we have any other opens. I was going to share the sheet where we're tracking things that we're working on, or thinking about working on next, kind of the what next, the future topic sheet, and we were prioritizing it last week. And so I propose we continue looking at it. We didn't finish, and I think some folks have added some things. So if there are no other topics, is that okay? Like if we, oh, Yogesh gave me a thumbs up. Okay, I'll share. Um, so let me get to the right. Sorry, it's just going to take me just a second to get it up. I should have had it ready. Um, so yeah, we're picking up after getting the last paper published, and I think we'll probably have some things that we wanted to get to that we didn't include, and I think some of them are listed in this document, but like I think Seb, I think you had some really good points that we couldn't get to, so uh, feel free to speak up. I'll try to find them too and add them back. We're not ignoring your comments from.
No worry.
Um, so what we've done, and Rama's been helping me with this, is we've listed the different work streams, and we're just putting topics in the different work streams for the purpose of coordination. Um, and so we can understand the big picture about who's working on what, so that we don't accidentally duplicate efforts. Um, and Ram, I don't know if you have any other comments about the other tabs, or what
Yeah.
what we want to do with them.
Yeah, just for reference, right? Like we added for the OCP GPU, RAS, and OCP CPU debug DAG work streams. What are the next things we're focusing on? Want to make sure like no duplication of effort happens, and we can leverage each other work stream strengths, and we can move fast. That is the reason, like even though those are CLA work streams, like we want to like just share the things going on, so that like teams can give feedback. Hey, this is the duplicate or whatever it is. Yeah.
Yeah. And I think FM is in the same state. It's an open group, but we're figuring out what's going on there. And RAS API, we have a pretty good idea of what's next. We're trying to get the spec out and trying to get like a redfish mapping demonstrated. So we're pretty focused there. I don't think that we're going to be looking for new topics in RAS API anytime soon, but we've got some things here so people kind of know what's going on.
Yeah,
Okay.
for GPU, RAS, and CPU debug and all, I just listed the items I didn't prioritize. Like, yeah. Okay.
Yeah. Well, and those work groups will have to do some of that prioritization too, right?
Yeah, there is a priority list. I put the like in that order. Like,
Oh, okay. This is in priority order.
yeah, but we can change it. Like, no, one RAS API should go up once we know that there is a next revision.
Yeah. I think once we get the next
Public.
revision
Yeah.
published and the redfish mapping done, then we're ready to talk. I agree
Yeah,
with
that will become the first priority.
yeah. I'm aligned with that.
Yeah.
And the blast radius reduction is pretty interesting too. So
Yeah.
okay. So we talked about a lot of these topics last week, and so we haven't done anything that is unchangeable, obviously. But what I'm trying to do is call it, is it done? Like we reviewed my poison document. I gave a presentation for a couple weeks. then we have high, we're doing like t-shirt sizes, big, medium, small, so high, medium, low. And then once we have a bunch of high priority things, we'll prioritize them. And then we've called some things filler. And so when we're between topics or, we just have a one-off thing, well, the scenarios are kind of nice because I'm hoping they just take a week or two at a time. So, the idea is that we just squeeze them in as convenient. I spoke to Anil this week. He and I had a one-on-one. He can't make it today, but he is working on more PCIe scenarios, and I think I've got a lot of them already listed here. But we'll flesh those out, and then we have to figure out how to contribute that. So that's what that means. I'm not sure about CXL, so we'll think about that later. We thought we'd come back to it. And so, last week we had gotten down to here, and I think, Dean and I were debating actually this one too and how this works. And so, Dean, I don't know how, like maybe you and I need to talk to you anyway because I found the things you were mentioning today. Dean and I met earlier and we're just talking about error severities. And so I found some things, and maybe what I'm also trying to work on, and this isn't nothing secret here, is I'm trying to align all of the severities from the RAS API and CPER, the hardware fault management document. But to do that, I kind of have to understand the severities that ARM has defined and Intel and AMD have defined, and they're documented. Like if you look at the programmers' reference manuals, for AMD and Intel, they're published, and so I'm using those public mappings to try to make a first stab at it. And so then what I'd like to do is meet with Vilas and Shibata and Dean, independently to see how bad I got it wrong and get it fixed, and then come here and show you all. And it'll just be a reference so that, because what I'm finding is that even in major operating systems, we don't always have the right assumptions about how severities are used. And so I caught some bugs by doing this exercise, so it's already been super fruitful for me. But I hope that it's okay, Vilas, Dean, and Shibata, that you can help me work to get this cleaned up to reflect what you do accurately.
Sure.
And sorry, when you say clean up severities, where did you clean up severities?
Well, so the problem is that I can even show you my. I'll flash up my horribly wrong list and show you what I'm doing, but it's wrong. So don't take anything I'm showing seriously. But the problem is that oh, somebody's on mute.
Shubhada, I think we can hear you.
Oh, sorry.
So I'm worried. This is horribly wrong.
Drafting something, sorry.
No worries. This is horribly, horribly wrong. So do not take this seriously at all. But the problem is that we have CPER and RAS API severities of informational corrected and recoverable and fatal. And we found that things weren't always used consistently. So like a few folks use deferred errors as informational, but that's not universally done. And some people ignore informational errors when they really need to pay attention to them because a deferred error might be there. So that's the kind of bug that I'm catching as I walk through this.
Yeah.
And we can add as many columns as there are severities. I'm not being prescriptive in the least here. All I'm trying to do is say, here are the different severities that exist, and here's how they map to CPER and the hardware fault management doc. And I'd like to publish this to OCP somehow and just use it to make sure that we're talking about the same thing. And like operating systems, I found some weirdness in operating systems where they aren't used correctly. And you can even just go look at source code. I mean, like you all could right now. And it's not maybe wrong, but it's just kind of like, huh, it's defined as recoverable, but it's not treated as recoverable. So that's the kind of thing I'm figuring out little things like that. And I hope you all don't mind me, so Dean, Vilas, and Shubhita, I am not trying to step on anyone's toes here. That's why I'm being really careful. And I hope
That's an important effort, actually, Drew. And I think it would probably be important to all in this forum have actually a consensus that can be shared through the OCP documentation as a general guidance. Because yeah, I agree with you, like especially around informational, for example. Yes, I think there is a lack of like a clear informational type of reporting. So you have to leverage other type of reporting, and it's not, I mean, it's not done the same way everywhere or for the same purpose. Yeah, I agree.
Yeah. So that's all. And this table's horribly wrong. It's like take it. It means nothing right now, other than it's going to have a least severe side and a most severe side. But the more I look at it, the more I think I got it wrong. So anyway, but I need so yeah, and Dean, I don't want to step on your toes either. So but if I can
No,
get
I'm
your
happy
help.
to have the conversation. I'm happy to help. We want to make sure that each of those contributors agree with what you want to finally publish. Because we might stand up and say, no, you got it wrong. But I think working together will prevent that. And that's what I'm here for.
Perfect. Thank you. Yeah, and what I've got is wrong. So yeah, like that's my caveat. But that's perfect. And if you agree to it, we're set.
Yeah,
You
and
know,
I mean, it seems like a good idea. Are you thinking about publishing a OCP document somehow, Drew, or like what is the outcome?
I don't know. I'm willing to debate that as well.
Drew,
I
maybe you
I
can
think we need to put it out in a way that people can see it.
This
maybe
needs,
best document I would say is hardware fault management main requirement. There is already we listed some severities there, but not this detail because that is the master for all work streams. If there is a maybe that is the best place to
Yep.
publish. Yeah, right.
so right now it's not aligning in the requirements document. That's where we started this, right?
Yeah.
So we definitely need to revise that document. So the document there can align with CPER because RAS API is aligned with CPER. So if it is in a form and fashion that it could be part of that document itself, maybe as an appendix or something, it'll be great.
Yeah, actually,
I'm very open. So Vilas, if you have concerns, I just want to
No,
publish
no.
it. It's,
Yeah,
it's,
I don't know. I was just asking. I think it's a great idea. It wasn't clear to me what the intended outcome was, but I think something like what they just said is fine.
yeah, I'm open to your ideas. So, like I said, I'm treading very carefully. I want you to steer me. I don't want to step on your toes. I want to be a good partner. I'm not trying to make anyone look bad or anything. I'm just trying to make sense of it because what I'm realizing as I dig into it, I'm like, huh, I really did not understand that nearly as much as I thought I did. Dean explained some things to me earlier today where I'm like, huh, my head hurts. My mind is blown and I wish I'd known this sooner. So, yeah, thank you. Thanks for being willing to help.
Yeah, I also have one concern though, like, as we go forward, like when is it that we want to uh, apply that, right? Because currently the way it is somehow seems to be working for everyone. But as we go forward towards RAS API, is that where we want to kind of unify that requirement, or
I think,
that
yeah,
I'm
I
just
think
trying to think what's practical versus what's ideal, right? That's
exactly. Yeah.
concern.
And I would even go further, Shivata, is yes, we can say that there is a RAS API mapping and a pre-RAS API mapping, and that's okay. I'm just trying to make sense of it because it's confusing.
outside of RAS
Okay.
itself, is there is there a possibility that different generations or product lines may have different way, or severity may vary within Intel products, for example, or within AMD products, for example, or that's not a likelihood?
I've not observed that, and the reason that it's somewhat stable, I think, is because the kernels look at the severities and act on them, and so that kind of forces it to be somewhat stable. It's like the details, there are nuances like how do you map it to CPER that vary, but the basic software responses are somewhat hard to change being in the kernel. So what I'm seeing is I think they're pretty stable. But I mean, the CPU folks could convince me I'm wrong.
What changes from generation to generation is, for example, sometimes it is decided for whatever reason that, okay, this class of error, we will change its severity. But what you're talking about what that severity means in terms of OS.
Yeah, I'm not trying to be too.
That will change. You're right. Yeah.
Yeah, I'm not trying to say, some sort of, cache retry error, making up some random error. I'm not trying to say that needs any severity. But if you think about it, the severities ultimately guide the software's response to the error. Like, can I recover? Do I need to panic? Right? If you look at, the Linux kernel, you'll see that it tries to grade them and say, do I crash? Do I recover? Or do I just keep running as if nothing happened?
Yeah, I think you'll find those nuanced differences in what is assigned more in the area of informational correctable UCNA
Yeah,
kind
I
of
agree.
things, and those are not so esoteric as in like something that's buried deep inside the cache, or it's more like JEDEC defined kind of things, and you have another message which says that action is taken or PCI action is taken, and how do product to product that severity changes. That I've seen that changing in past couple of generations. That's
Okay.
one.
Well, and like it'd be really nice if one of the outcomes of the RAS API was that we're a little bit more consistent in how we, note these things. So
Yeah, that's why the question, right? So we will go with the latest and greatest what we have at the time of writing, and I mean, really the question is to be answered by silicon vendors. That's the severity they assign for if we're using certain examples, for example.
yeah, and like I'm finding some severities aren't used everywhere. Some silicon has some severities that others don't, and that's fine. We just say NA, no big deal. So okay, well, thank you. What I'm doing is, I'm finding that I'm learning just a ton from doing this, and so I think it would be valuable for other people. And beautiful if we have really clear definitions of this, it would help other software writers, because like I've been talking to some of the Windows folks about these severities, and they're learning things too. So if we could, and like I think that sometimes an unrecoverable error is recoverable because it was task recoverable or something, or no, task unrecoverable but host recoverable. And so if we can get some of those nuances fleshed out, I think it'll help us when we have our discussions. Because if you look at the error severities that we've probably in the hardware fault management document spent about on the order of 40 hours discussing. It feels like maybe it's not 40, but it seems like we have spent so many hours discussing those severities. And what I'm realizing is because we don't all have matching understandings. So, okay, well, thanks. I'm sorry I rambled so long on that, but it's been really, I've really learned a lot. I mean, I'm really glad I want to work on it.
Yeah, I mean,
Okay, so then and by the way, Anil couldn't be here today, and we talked ahead of time, so I know he cares about the PCIe errors. Mita is out for a few weeks too, so she kind of let me know what, I think we've got the key things she cared about. We'll check back with her when she gets back. So let's keep going though. So one of the topics, so we're walking through future topics. We said that the storage was less interesting, and that was feedback from Mita. And really, I think it is lower interest, but not that storage isn't important, but just because it's not the biggest burning pain point. The storage error handling works, pretty well. So that's why it's not that it's not important. It's just that it's not a pain point. So next up is NICs. Do we cover NICs here? I don't know. I mean, like in terms of PCIe errors, you bet. Is there another group handling NIC reliability, or do we talk about it?
Well, do we have people here that can sensibly talk about NIC reliability?
I'm not sure that we do. So I'm thinking that means it's low. No one's standing up and saying it's it may not have the experts here. Okay.
And I mean, to be clear, I think the HWFM requirement stock applies equally well to NICs as it does to anything else. But beyond that, I just don't know that we have the people. Okay.
Completely agree with you. Yeah. It's the general stuff is completely true for NICs, but the NICs, we don't have anything NIC specific particularly that I'm aware of. So what about optical interconnects? I think it's kind of the same as NICs, right?
Probably. There's an interface. So the optical interconnect, I'm not sure what's the interface to an optical interconnect. Is that PCIe also already? So there must be some
Well,
kind of translation or transport of errors.
Yeah,
right.
we do.
Oh, go ahead. I'm sorry.
Gen 6 already has that, right? And we have got certain companies that have already demoed optical interconnects with PCI. Absolutely.
Oh, so I'll put perhaps optical PCIe.
Yeah. There are a lot of optical work streams in OCP. I don't know, and I suspect some of them are covering optical reliability and stuff, but I don't know to what depth. So
Yeah, maybe we should just connect to them and make sure that they align to our requirements.
Yep.
Okay. Yeah, I think that sounds pretty reasonable. Just make sure we're working in the same direction. Okay, liquid cooling, I think is kind of the same.
Although that one is curious to me, actually, I think that one is different.
Okay.
Because liquid cooling only defines the thermal for your machine or components. And I mean, it works, it doesn't work. Errors may happen sooner, faster, more often if you don't have adequate cooling. But from, I think, a RAS perspective, it's kind of orthogonal, right?
Yeah, I think what you're really saying is it's out of scope, and I tend to agree.
Yeah.
So, yeah, and I guess, maybe we need to, like you were saying, Vilas, there are people working on cooling. Maybe, like I've been working in some of Microsoft's cooling solutions. In fact, I have a meeting right after this about that. And you know, that's really the question that always comes up with thermal stuff is how do you correlate the temperature weirdness with errors? And
Yeah, but you see there, it's not about cooling
Yeah.
as much as thermal density, for example. The risk is thermal density that creates marginalities and things like that.
But
And
it's not specific to liquid cooling. Like that can happen with air
yeah,
cooling. I
yes,
mean, yeah.
yes, I
sure.
agree with
The
this.
only, yeah, okay. If you look at it that way, I agree with you. The only real liquid cooling specific item is leak detection, and but I think they've already, you know, there's no. Well, I guess we want to know if system's got its power yanked because the leak detector went off, but that's about it. So I think you're right. We can just call it out of scope, and then you know we just all the hyperscalers have to work with folks looking for leaks to make sure that we can correlate those to machines going down. Okay, I buy that. So resets, we had deferred this because it was in the hardware fault management requirements document, and we talked about warm resets and when warm resets were needed. And then we said, well, what even is a warm reset? Uh, and so Charlie has been sidetracked. I've also been talking to him, and he's sidetracked right now, but he did start something here, and I imagine that we're going to have, you know, that this is an interesting topic, but I don't, you know, I don't know if it's urgent. But every time we talk about it, it seems like people are not quite aligned.
Okay, I thought that that one was fairly simple, but maybe it's not. But the reason, in my mind, the reason we need different types of reset is because ultimately RAS is there to signal a problem with the system, and we need to have access to that information. So if the problem limits the access to the information, we have a RAS problem there. We don't know what's going on, right? So we need a way of resetting the machine so that we keep the information we need for RAS, but we can access it, right? So, and that's, to me, that's the only, so I don't know if I'm missing something, but that's why we need a warm reset. The concept of warm reset is you reset pretty much everything but anything relevant to RAS, and then you access the RAS
Well, and
information.
there's some containment implications in there too, but I don't think they're that complicated.
Mhm.
I have a proposal then. You know, if Seb, if you, yeah, maybe it's clearer for you, but if you want to document like the different types of, I think there's cold reset, there may be a fatal error reset, a warm reset, a power on reset, you know, but if you want to put them in the glossary of the hardware fault management requirement documents for the next version, then what we
Mhm.
do is just have a session where we review those and we call it filler.
Okay,
I mean,
sure.
is that okay?
Yeah.
Okay. And you know, uh, well,
Or, you know, I don't know who is Charlie, but if Charlie is already working on something, then, you know,
he's
maybe,
going to be out for a while.
okay,
So I think he won't be offended if we do it, you know,
okay.
without, you know, I talk to him all the time. He's okay. Um, so,
Yeah, sorry, hold on. Dean, were you gonna say something on this?
you're on
Dean?
mute if you're talking,
Yeah.
Dean.
Oh, yes, you're right. No, I was rustling papers, but I do have to drop, so sorry, but I need to leave now.
Yeah, okay.
Okay.
Yeah, Drew, the reset thing, it's gonna get more complicated. And so, I mean, I don't know. I'm fine with it. Like, I worry that there's gonna be, because this is just, like, especially for Intel and AMD, there's a lot of like legacy stuff for devices. A reset is a completely different thing than for a CPU. Like, there's just a lot of complexity around that. So,
Okay.
but that's okay.
Yeah,
Sorry.
and would it be
Yeah.
relevant here? Like, is
That's
it related to the RAS aspect?
Where it's, I think, related is just for from a blast radius perspective. If you have to reset something to access the RAS information, that's where, you know, potentially whether you can keep a device alive or whether no, you lose it because you have to go through a warm reset, and the granularity of your warm reset is kind of, well, the whole device or the whole socket. Or,
I think the third question is, besides being educational, what outcome do we expect for hardware handling? I mean, for whatever specification or requirements we are coming out with here.
Well, I think I can answer that, Yogesh. We were talking about warm reset in the document, but we got wrapped around the axle on what it meant. So it was something we were discussing because it falls into a lot of layer handling scenarios. So
I mean, it would have only educational value, right? Like, okay, how can we reduce blast radius with for certain types? But yeah, practical implementation would be something each vendor would have to decide, right?
agreed. I
It's
think
very complex.
I agree. That's why I think, Drew, you put just glossary, right? It's
That's
not
exactly
a
that is
section.
exactly why I made it a glossary entry. We're saying, hey, sometimes you have to do a reset to contain things, and maybe you reboot to you do some sort of reset into firmware to log errors. And I mean
Yeah. And
I'm not trying to get all the nuances spelled out.
and maybe said if I mean the way you described it, it's more of a like it's a requirement that certain types of behaviors be supported, right? Like you were saying, right? Like you might need to reset in order to get access to the error logs or whatever. I think if we write it up that way and stick it in, I think that's much easier, right? Than trying to say a warm reset is this. Right?
I think maybe related, but I think I recall seeing in CPU, the other work stream, the C11 drama. Isn't that where talking about some blast radius reduction requirements?
Yeah, in the
And
GPU for AI cluster. Yeah. Yes,
So
Yogi.
we're not trying. Let's just have some glossary entries on the line on what a warm reset is to start.
if you don't mind, let Rama answer. I want to hear what he has to say about that work streams approach. Sorry.
Yeah. Like that will Yogesh, that work stream focused on the AI cluster efficiencies due to different errors and how the blast radius impacts. Okay. And like Seb, the question you're asking is like there is some confusion or like in the industry or how the OS implements or like questions or requirements. I think
reset is a tool in handling faults, and where a variety of resets give variety of handling capabilities, and that's glossary item. But I think besides that,
yeah.
I don't know. I mean, actually,
Like we ought to see the value out of the work we are doing. Like,
Well,
if
it came up in discussions as we walked through scenarios, and people said, "What's a warm reset?" Because it was referenced in the hardware fault management.
not we agreeing with that. Yeah, we know because we spent so much time.
Let me chime in. Sorry, I had.
Oh, good, you made it. I was telling people you couldn't make it today.
Yeah, so I want to clarify, right? I think we need to do some maybe one pager. Two things. One is there's a lot of legacy resets, different type of resets, and people always get confused. So just a simple write-up of each type of reset, how what industry definitions are. And also harmonize between what x86 world has done, what ARM world is doing. So that's one approach, one part of this ambiguity that we need to clarify here, maybe white paper or one pager. And then second part is what I think Drew and Vilaj, you're saying, okay, what is our requirement from a resets, from a different type of error behavior, and what should be the scope of the resets? Should this erase the sticky register or error information? Should it just confined to a device alone, not the host, things like that. So that's from a requirement point of view, different type of resets, and what should be the scope, blast radius associated with that. And the first part is to just document and remove the ambiguities in the industry about different type of resets people talk about.
So I have a proposal then, Anil. Maybe we can start with just a few glossary entries to define what they are as kind of a starting point, and then build the one pager off of that if we find this confusion, or if you want to help us do the one pager, that I'm not opposed to it, but I was just thinking we could do something quick with the glossary entries and make a little bit of progress, and then do the more complicated things second.
Yeah, absolutely. I mean, I learned something in the ARM world, there's something called synchronous abort, and so okay, what the heck is that? Right? And so it's interesting learning, right? So let's document it, because some information is out there in the public, but people don't know how to understand that. And then when you put in one table, then say, aha, okay, this is how it is done here, this is how it's done here. Now I can understand how to interpret these interrupts.
Okay. You're going to say something, Vilas?
No, I was gonna say, yeah, let's just write something down and then we can all look at it. I think that's probably the easiest way to figure out
Okay.
if
So
we're gonna.
yeah, so I'll say we'll start with and later Anil may build a document that describes these further. And I'm not, and you can do the like Anil, I think that's a great idea.
Yeah,
Okay.
Put with the ad so that I get notifications. Sorry, otherwise.
Well,
I don't know if it's possible. At Anil, or maybe that's some reminder. Thank you.
Okay. Okay. So then I think the next one, do we still have Rama? Yeah. So Rama, we had talked about we're trying to synchronize in this work stream across a bunch of other work streams. So we had talked about maybe we could review the crash dump and debug dump stuff. I don't know what you're thinking. I'm open to ideas though.
Yeah, maybe like we can go through that current spec is a 0.7 is publicly released, right? There are some questions or like and feedback. I think that is the most valuable thing, right? Hey, maybe it's still 0.7, right? Maybe we can schedule one day to go through that.
Okay.
Yeah.
If I may ask something, bring up here, very hot from the press. So besides crash dump and debug dump that we have talked so far, I'm pretty sure we are familiar with the kdump, which is the host kernel. And in the accelerator world, there is a core dump also. And both these kdump and core dump are very meaningful. And some use cases overlap with what we intend to do. Some actually are kind of orthogonal because kdump is used for many other use cases, not just for debugging purpose.
Yeah.
So I think we should expand the scope here. At least I'm thinking too loudly here. I don't know if everybody agrees with that. To include the kdump and core dump as well.
Yeah,
So
it's a good point. One quick question, Anil. Like, let's say we describe it, is your intent is like because that is like, say, Linux is like standard. I don't know whether they standardize it fully, right? How like is the ask is to go work with Linux community to standardize, expand, or what? Because we cannot influence fully from this work stream. What is your thinking? Like,
Yeah, so basically the thought here is that, okay, kernel takes a kdump when there's an exception.
yes.
How does information propagate? How do we pull out from the machine? I'm looking from a like a overall infrastructure point of view. And we can communicate a standard way of translating kdump to some meaningful format. And then we can use our parser. Let's say we keep collecting these key dumps in our infrastructure, and Drew talked about getting all these logs in a centralized location and post-processing it, decoding it, and then come up with a CPAD. Right? So how can we tie this key dump infrastructure that exists today with some incremental improvements into our existing debug flows?
So I think that's an interesting topic. Like sometimes cloud providers a little bit more limited in what we can collect because we have to protect our customers' data. But like back in the day when I worked at a vertically integrated server company on HPUX, we would do extraordinary things when there was a viral error. So every single class of error, we would reassemble the system. It was like bringing the system back up in the face of extreme failures, clear viral mode, go to the do a whole bunch of register collections and stuff them somewhere, and then hand off to the kernel. The kernel would go do a dump, and we get all these kernel dumps and core dumps from processes, and then it was called a tombstone. And the beautiful thing about that is that I could strongly correlate what the kernel saw and what the kernel was doing at the time that hardware took the air. I could see every process. Now, obviously, that doesn't fly in today's environment with security, but I imagine that I could put out a marker that goes in a hardware error log that would also show up in the kernel dump. And so and I've talked to many of you about this before. So if there is let's say a crash dump from hardware, and I had a problem in a software and a customer is angry, I might go tell them, hey, go look at your dump files from the OS and find one that contains this GUID, this marker that we put in a certain place that's collected in the crash dump. When you find that one, or give me the GUIDs of the crashes you care about, I will go look at my hardware error records, I'll correlate them, and if you're willing to share your OS dump with me, then I can figure out exactly what your processes were doing, or maybe I can have you help me tell me what the processes were doing. So I think there is something there, Neil. We're just going to have to work around the security constraints of not being able to see what the OS is doing all the time.
Yeah, so mechanism of how we consolidate this, right? You're right, is implementation specific. What we want to define here is what exists today in the KDOM. Is anything can be done there, like with a marker or some format data that we can correlate? Put the solution together. Now, how it is actually implemented will depend upon hyperscalers with VM machines, calling VM machine or bare metal or fully integrated, stack. Will try to implement differently.
Well, and I think there's a way we could do it that works pretty generically, like a GUID in the logs.
Right.
So.
Yeah, I'll tell you one very useful or uses that I came across was a machine was crashing hard, okay, and even crashtime didn't have enough information. And guess what? There was a PCI encrypted error, and the kdump did capture that log because before machine resets, kdump completes, and then all the errors are gone because it's a reset AC cycle. So we couldn't find any breadcrumbs except in kdump. And that's how we were able to figure out, oh, there was a PCI error, which is not a part of the spec, is somebody else, some other device was spinning through the driver, splitting the log, and kernel picked it up.
Yeah, I agree. There is a lot of valuable information. Right now, we privately work with like our kernel team, a lot of collaboration. I think is the idea, Anil, is to work with Linux community, get the summary and put into our spec, or like, I know idea is good. How do we standardize? You want to invite some Linux people in this work stream, or you work outside and bring the summary here?
Yeah, I mean, we can start from some basic skeleton thought process. First thing is, without making any change in the kdump, how do we pull the kdump out and put it in outside the machine, take it outside the machine, either through out-of-band or in-band, right, through our existing infrastructure that we already defined. Can we do that? If not, then what?
And like to build on what you're saying, Anil, a lot of kdumps would have I think they collect machine check registers in some of them. if I had a machine check register that had a GUID in it, I could, with no change to the KDump, correlate it to things I'm selecting out of band.
Yeah. And then the other thing I was finding out the code. So code dump, basically it's like device specific code dump, let's put it this way, or accelerator specific code dump.
Oh, okay. So thank you. I wasn't quite clear on
Yeah.
that. So I'll add that.
Yeah,
Yeah.
we briefly listed that into GPU RASPEC. We didn't expand specifically. We just said.
Right. This is so important, by the way, because
Yeah.
in the accelerator world, the devices have active CPUs or processors, right? And with their own kernel or whatever. And if something happens there and the device hangs or goes into some exception, then these core dumps are so useful to figure out
I
what
agree.
really happened.
Maybe we should
And
ask some silicon vendors here. Like
yeah, so what we want to do here is not to get into the implementation because we are implementing differently. I'm sure other accelerators may be doing differently. We just want to define that, hey, we need a core dump to be pulled out from the accelerators, right?
Well,
And,
and while we're dreaming, Anil, I'd like to see that core dump come out the RAS API. So
perfect. Yeah, yeah. And define, and because in some cases, the only way we can correct is out of band, and a lot of cases it will be in band because when a device hangs, the host may still be alive and can still.
sure.
Right?
Yeah, I was just going to ask whether you're thinking of this in band or out of band.
That's
the
why I
core
said
dump.
RAS API. So, but as I was thinking
Yeah.
both.
Yeah.
Mhm.
So that's the beauty of this code, right? We can pull out in band also, and it can tell us a lot of stuff that eventually will crash the machine probably. But
Yeah.
right.
Mhm.
Well, and the driver, like you may know something in the host because the driver's in the middle of something. So, we may be able to get additional logs from the driver, but like the key problem I see with PCIe devices kind of universally is that we don't have a standard way to collect logs from them. So, there's nothing like machine check banks. So if a PCIe device generates poison today, there's no way to get that unless you have some extraordinary driver writer that tells the OS and does amazing things. But I've never seen that. And so I think what you're talking about, Anil, is like a combination of software goodness, but we also need the same exact path plumbed for hardware. And so that's why I said RAS API might be a good answer because it'll work in band or out of band. And it would be a path that would be standard for all PCI devices to say, here's what happened on me.
Yeah. I mean, once RAS API is all implemented, then that'll be the right approach. But until then,
We got to.
yeah.
I think RAS API has so many advantages. I feel like prioritizing that compared to so many year low priority thing.
I mean, it'll take its own
I would say
time.
like use this meeting also sometimes like non-CLA things, like focus on RAS API, get things out. That way, I think we all get benefited. I think, yeah, like that is
So
very.
I'll add that RAS API reviews because I think
Yeah.
as we get to things like this redfish mapping, we
Yeah.
we ultimately want to have a redfish open source thing that you can just download and start making RAS API calls over redfish. And it's not real, it's a fake thing. It's like a fake BMC that you could talk to. And Anil, if you want to come up with a in-band simulator, we're open to adding the in-band simulator. We just happen to have a BMC that we can do redfish in quickly. So we're going down the path of least resistance for the redfish mapping.
Mhm.
But we'd like to
Hey, given that, just one addition to the topic that we should consider for a couple of weeks, next week and after, right, is the review of the 0.81 document release, right, for RAS API.
I think that we have to do in that meeting. We don't want to review the entire document.
Oh, we can't review it here? Okay.
I think
Not the entire document, only concepts. I would,
let this be a highest priority standing pillar, or basically an interrupt that can that's highest priority.
Yeah.
Let's use this time as much as possible within the constraints of the CA.
I think what Drew mentioned, like the POC requirements to accelerate RAS API implementation is still a topic here to discuss here. To just define this POC, so that we are all on the same page. Okay, this is what we're going to see at the end of the, in the next.
I think we can talk about the requirements, but at a high level. But once we get into details, then we pretty much have to. It gets very challenging to keep it CLA.
And just to be clear, I'll let you jump in, but if anyone's wondering, because I know we have some new folks today, the RAS API is an open CLA group. That means you have to sign a contributor license agreement to participate. But the reason we have that is to protect the openness of the spec. It is not to exclude people. So if you want to join, just come sign the CLA. And as soon as we hear that you've signed the CLA, you're invited to all the RAS API discussion. So I just wanted to put that plug in to sign the CLA, so you can be in the closed discussions. Okay, and
So
and
the topic I would suggest say RAS API POC. Maybe that's is actionable thing, right?
Yeah, we could, I could go over what we're doing for the POC, and it would be high level, like Yogesh said. It'd be the concept of the POC and mapping it to the hardware fault management architecture. So we could do that here. And I mean, Yogesh, I think we'd be careful not to discuss specifics of the interface, but just the kind of the big picture of what we're trying to accomplish with the POC. Do you agree?
And the timeline also, right?
Yeah. The timeline's yesterday, but I mean, we're trying to do as fast as we can. But Yogesh, is that okay with you? Like if we have a few slides about, the goal of the POC but none of the details of the implementation?
I agree, but I think we are trying to. So yeah, let's talk offline. But yeah, I think we definitely want to discuss it here. Not opposing that at all, but
Okay.
we just want to be also mindful of getting folks like Hari and I don't know, Mohan and whoever else together. There may be some logistics challenges, and also
Yeah, I wouldn't go over any of the details of what Harry's doing quite yet. Carlos and I are meeting with him pretty much weekly right now, and maybe even a little bit more to do this mapping. And so we've given him feedback. He's doing the next round. But I mean, like, it's just going to take a few weeks for us to ramp Harry up to even what we're doing, because it takes a little while to understand it.
And as a closing thing, and I apologize for asking you in open meeting, but we have this AR, which means I think I'm expecting you to follow up with Samir and Hari and Vilas and Dean to have this. Yeah, so yeah, just reminder. Sorry.
And what he's talking about is Samir from ARM is going to help us with the PLDM mapping. So, and our goal is to take every mapping of the RAS API to DMTF. So there'll be a PLDM mapping, a redfish mapping, and it'll be a DMTF doc that actually spells out the.
Well, let's take this last question from Sakul and then end this.
And I would like to put a plug in, update the sheet and like put comments in, update, give us feedback, and we'll continue this next week.
Yeah,
go ahead.
Drew, can you involve me in the PLDM discussion when that happens?
We already talked about that, so Drew is schedule a meeting. So
it's gonna be
Sure.
and our goal is to be as open as we can within the RAS API CLA constraint. So
and we can also do Shubhday. Sorry, Drew, I'm cutting you the time. But I think what we can also do is when we do that, if you want to invite, welcome.
Yeah, hi Drew. So are we keeping the error correction in quantum computers out of scope?
At present, I don't think they're like when they're getting close to a real product, we can talk about them. But the problem is that I'm being pushed to map the work I'm doing to deliverables. Like when's it going to be in the data center? And if anyone asks me when's a quantum computer going to be deployed at scale,
first we need a fleet of computers first.
I don't know. Yeah, so I think Sakul, I'd be interested in talking about it, but I think it may be a little while. Like when we're on the cusp of when we're designing the first practical quantum computing systems, maybe we can come back to it.
Yeah, so apparently, I mean, we have been hearing grand news and even like 13,000 times scale up in the compute time by your former employer and even your current
Yeah.
employers.
Google has
So
Google's had, it looks like a pretty big breakthrough. Yeah. But that doesn't mean that they're being deployed at scale yet. I think it's still a lab product.
of course, yeah.
Which is verifiable. That's the first big feat. So,
It's exciting though. I mean, I'm
Yes, sure.
I'm excited to see what they come up with. Yeah, it looks awesome.
yeah, there were some really good discussions, and me and Carlos attended one about error correction in quantum. There was a whole session about quantum at the OCP Global Summit in Future Technologies. So look for, if you're interested, you might want to check those out. I think they released the recordings of those too. So, okay.
Yes, yoga, yes. I did. I too attended that. Yes, yes.
All right, then. I think this is it for today, then, Drew.
Sounds good.
Happy Halloween, guys.
Yeah, happy Halloween, and thanks for all the
Yeah.
feedback. Please add your feedback to the doc. You know, if you disagree with something or you have comments or you want to add something, you know, let's do a good job planning. Thanks, everybody.
Right. Good. Happy Halloween. Bye.
Happy Halloween.